What's going on, guys? Your everyday math tutor here, and in today's video we are tasked in finding f prime of x when f of x is equal to x cubed minus 3x. So we're going to be using the definition of a derivative, and as always I like to write it down to remind myself what that is and get used to it, or at least try to remember it for next time, so I don't have to keep writing it down. It's always a good thing to write it down so you remember. But anyways, we have x prime of x is equal to the limit of f of x plus h minus f of x in the numerator. That's going to be over h as h approaches 0. And that is the definition of a derivative. So now let's go ahead and write it down with the function that's given. So we have f prime of x is equal to the limit, and instead of having x cubed minus 3x, we're just going to substitute the x plus h into that function. So we're going to have x plus h instead of the x, and we're going to have it cubed minus 3, and instead of having x again, we have x plus h minus, now we could just rewrite the original expression. That is x cubed minus 3x. Okay, so all I did there was rewrite the original expression or original function with x plus h and then subtracted the original function. That is, of course, over h according to the definition, and as h approaches 0, of course. And now we can expand to get rid of the parentheses. So we have f prime of x is equal to the limit. And this is what I like to do here if I don't know it immediately. I just write one of the x plus h there, and then I do know what x squared plus h or x plus h squared is from the top of my head, which is x squared plus 2xh plus h squared, and then I'll just I'll start to distribute afterwards, but let me expand the rest of the numerator here. We have negative 3x minus 3h minus x cubed minus, or plus 3x rather. We are multiplying a negative there. And that's going to be over h as h approaches 0. And now let's move on to distributing the terms in the first parentheses into the second parentheses. So we have f prime of x is equal to the limit, and x times x squared is x cubed, and x times 2xh is going to be plus 2x squared h, and then finally the final x that's going to be multiplied to the h squared, so that's going to be plus 8 or plus xh squared. And now we have to multiply the h to every term inside the second parentheses. That is going to be plus x squared h plus 2xh squared, and then h cube. And instead of rewriting this entire thing, I'm going to go ahead and just simplify it. We can get rid of the negative 3x because we have negative 3x plus 3x, which is 0, and nothing else can be combined. So we just rewrite the minus 3h minus x cube. And of course, that is all over h as h approaches 0. And now we combine like terms. So I like to, what I'm going to be eliminating, I like to just scribble scrabble. So x cubed minus x cubed is 0. Let's see if there's anything else we can eliminate. I think we could combine. So what I could combine are the x squares. So here I have a 2x squared h and an x squared h. That is going to be f prime of x is equal to the limit of 3x squared h. And then I have the h squares, so I'm going to circle that. Those are both positive, so now I have plus 3xh squared. And then I just rewrite the final two expressions here, plus, or terms, plus h cubed minus 3h, and that of course is over h as h approaches 0. So now I could factor out the h, which is in most cases when we use the derivative or the definition of the derivative, we're going to end up having to factor out the h anyways towards the end of the problem. So we have f prime of x is equal to the limit of h, which is factored out. We could factor out. It's a common variable there. We're going to have 3x squared plus 3xh plus h squared minus 3. and that's over h as h approaches 0. So what we see here is that we have an h in the numerator and an h in the denominator, so those could cancel out. We then have f prime of x is equal to the limit of 3x squared plus 3xh plus h squared minus 3. Just rewrote what was inside the parentheses. No longer have to put it over h since that was eliminated, and that of course is as h approaches 0. And now we can evaluate the limit. Now we can substitute 0 into wherever we see h, so these two terms in the middle could eliminate, and we are left with f prime of x is equal to 3x squared minus 3, and this is our final answer.